things to cover. First one is how did we get here? This again is basically just for information. It doesn't have to do with your own observations, but it's kind of interesting nonetheless. The universe is about 14 billion years old, which always strikes me as a very low number, because the Milky Way galaxy formed about 2 billion years after the Big Bang. So I always find it interesting that the Milky Way has been around for basically most of the age of the universe. 5 billion years ago, the sun of the solar system forms, and about 1 billion years after that, which is also a fascinating number to me, it took about 1 billion years for primitive life to form on Earth. These are single-celled organisms in colonies. Humans evolved about 100,000 years ago in modern Africa, and then we got agriculture about 20,000 years ago. So on the scale of the universe, although the Milky Way is an old fogey, humans have only been around for a very, very short period of time, and humans in cities with agriculture even shorter than that. This is oftentimes expressed as what's called a cosmic calendar or a cosmic timeline. It's a little bit hokey, but it gets the point across that if we compressed all of the history of the universe into one calendar year, these dates would correspond to various events in that year. So it takes about a month for the Milky Way to form. First life on Earth takes over 9 months, almost 10 months there. Dinosaurs come about on about Christmas. Dinosaurs die off on the December 30th, so we're already approaching the end of the year. We're getting to the end here. Dinosaurs only made it 4 days. We think of them as being really long-lived, but in the scale of the universe, it's not so long. And then finally, on the last day of the year, with 2 minutes to go, we get modern humans. Agriculture with about 25 seconds. Pyramids were built with 11 seconds, and then this is not for you guys, but for my 18 and 19-year-old students. 0.05 seconds ago you were born, so you guys might be
What are you trying to say there?
some number higher than this. Higher than this, but less than this. There you go. This video here, again, we'll skip it in the interest of time. You'll have access to all these slides. It's actually a modern version of the Cosmos series from Carl Sagan. This one was done by Neil deGrasse Tyson, I guess 4 or 5 years ago? I kind of forget. Where he just explains the cosmic calendar. It's basically all of this with fancy graphics and things happening. But same information.
So what are we expanding into?
Oh man, I got that question already. What can I get away with? Space itself is expanding.
Into what?
The universe is all space. And so the universe itself doesn't expand into anything because it already is everything.
Space is expanding into space.
It's not expanding into anything in the normal sense. Space itself is getting bigger. We'll do that later.
Kind of like your brain right now.
That's more of a that's a second kind of concept. All right, this is really where I wanted to go with this lecture. How are we moving? So at each scale that we've talked about so far, there is an associated motion. And as you'll see when you start taking data, that motion translates into some aspect that you can actually see with your little tiny telescopes, which is really cool. So the first and most obvious motion is that the Earth is rotating, right? We have days. So that one you know. The second and also equally obvious one is that the Earth is orbiting the Sun. And so that's why we have changes throughout the year in our weather, for instance. These two motions will affect your data, because you can imagine if you are, let's say, here in the orbit, looking this way, things will be moving differently than if you are, say, here in your orbit, also looking this way, but moving that way. And so the direction of your motion in the universe is going to affect your observation. And we'll see that in the later part of this week. The sun itself is moving more or less randomly within its local volume. We have to remove that motion from our observation. The sun is moving around the center of the Milky Way. So if you kind of imagine that this galaxy is a pinwheel that's rotating, that's more or less correct. Galaxy is all rotating, and all of the stars and all of the gas and dust is rotating with it. When you guys take your data, you will be able to see that rotation in your data, which is really cool. But in order to calibrate that, we'll have to compensate for some of these other motions. So here the sun is going around the center of the Milky Way. That whole orbit takes about 300 million years. So we could, I won't go through this entire exercise, but you could think of the cosmic calendar in terms of that 300 million year orbit. So let's see, the dinosaurs died off about 65 million years ago, right? Which is maybe 9 o'clock. So they died off about here. And the dinosaurs, let's see, when did they come into existence? 300 million years ago? About?
December 26th.
December 26th. Right, December 26th, 3 million BC. So 300 million BC. So that was about here. So here's dinosaurs. That's not bad. And then, you know, humans is like here to here. So you can kind of qualitatively think about things in terms of the solar orbit about the Milky Way. Just like the sun, though, I want to stress that everything in the Milky Way is orbiting the center. The Milky Way itself is moving towards Andromeda. They're actually on a collision course, and they will collide with each other in some small number of billions of years. I kind of forget, 5 billion years maybe. When that happens, all the stars will basically just pass through each other with no effect. Because again, there's not really much out there in space, even within our galaxy. And then the universe as a whole is expanding. We won't deal with this. So let's save those questions.
Or will they actually coalesce and stay together as one more?
Yeah, they'll pass through multiple times, and then eventually they'll make one bigger galaxy. The only thing that will interact significantly is the gas and dust in them. For the same reason that the Milky Way forms a planar structure, a disk structure, because there's friction there. And so the gas and dust will dissipate via friction, and they will coalesce into larger gas clouds and initiate larger star formation episodes. But the stars themselves will basically just go straight through. So the sun, if it's still around by then, will pass unimpeded through Andromeda, and then we'll have a new galactic home. Milky Way will be brighter, but otherwise things won't change a whole lot.